and get started, Geoff.
Super. All right. Well, welcome everyone to this Friday webinar. We're going to keep it under an hour, and depending on Q&A, we might do some follow-up if we don't get to everyone's questions. So the subject is commercial solar, roof to profit center, how solar energy is transforming your business. My name is Geoff Greenfield. I'm the founder and president of Third Sun Solar, by the way. And Caitlin is our marketing director, and she's kind of facilitating some of the Q&A and making these webinars happen. So we're going to go over a little bit about what qualifies me and Third Sun Solar to tell anybody anything about solar and commercial, what our experience and expertise is. We'll talk a little bit about the solar resource in Ohio and the Midwest. It's a popular concern. Talk about today's technology. Even folks that have looked into solar as little as 5 years ago are a little bit behind because it's a evolving technology and today's numbers are a lot better. We'll talk about some typical concerns that people have with performance, durability, penetrations, and roof warranties, and then obviously where the rubber hits the road, project economics. We'll go over some case studies to give you an idea of what some of these projects look like, and then reserve time for Q&A, which Caitlin will be compiling through the chat throughout the presentation. So we are celebrating our 20th year of doing solar projects in Ohio and the regional area. We've done projects in 16 states over the years, but right now our primary focus is Indiana, Ohio, Michigan, Pennsylvania, Kentucky. And then primarily Ohio. We are, again, doing this for 20 years. We're a full service design build firm, or sometimes in the jargon, they call it an EPC, engineering, procurement, construction. We'll talk a little bit later about why that's an advantage for our clients. Here's one of our projects in Springfield, Ohio. And we're about 50-50 residential. We do a lot of residential work. It's great because it keeps our commercial crews engaged in between the large commercial projects. We can stage many smaller residential projects. According to an industry trade magazine, we are the #1 solar installer in Ohio. We're full service. Besides the design and engineering piece, we do feasibility analysis, consulting. We've consulted for units of government, cities. We do economic modeling. We structure the finance for projects. We'll get into that a little bit later. We obviously do the design. And then if you've ever gotten on the internet and looked at some solar information, there's thousands of manufacturers and suppliers all claiming to be the best. And that's one of the big values that we bring to our clients is sorting out the truth from the marketing. We do the installation, and then obviously over the life of these systems, there are maintenance issues, and we're a full service and maintenance provider. As I said, #1 in Ohio. Nationally, we're ranked number 28 for commercial EPC services, and we're 160 overall in the nation on this top 500 list. Over the years, we've served lots of marquee brand clients and plenty of other, small but important family businesses in Ohio. We do national projects for the federal and state and local governments, and then lots of institutional and educational projects. I'm not going to read these to you. Over the years, we've won awards. Now, an important part of what we do is we procure the equipment. That's the larger part of the solar contract is made up of the actual equipment that goes on the roof or on the ground. And so we joined Amicus along with 57 other companies across the country that are right now doing a little bit more than $750 million worth of procurement. So we can bring that volume procurement to our projects here in Ohio, giving a cost advantage to our clients. Let's see, one of the things people look at is whether or not we're stable, and we are A+ business, Dun & Bradstreet verified. And we are a B corporation. So we're actually third-party certified as a triple bottom line company. What that means for our clients is that the employees that are going to be actually up on the roof or in your electrical room doing work with you are treated a lot better than most other companies treat their labor resources. And that's just one of the ways why it brings in value to our clients. So I mentioned design. One of the things that having an integrated, experienced designer does is we learn from our mistakes. We learn from all the projects that we design, and then after we build them, during the build, we learn about what could have gone better, what could have gone faster, what could have been more efficient, what could have led to a higher performance. And we've got 20 years of that feedback loop, basically making our designs better and better. Everything that we do is fully stamped by professional engineers to meet state, local, international building codes. And above and beyond the building codes, we're really focused on long-term performance. And then NABCEP, North American Board of Certified Energy Practitioners. It's kind of like our industry gold standard certification body. We have NABCEP employees, as well as myself being on the board of directors of NABCEP. Now it's an international organization, and it's definitely something that at a bare minimum, any commercial installer should have a NABCEP certification. Our culture is really what most folks are looking at when they evaluate us as a partner. We are mission driven to accelerate the shift to clean energy. And we, like many businesses, have a set of core values. Ours are based on service, reliability, being driven to go get the job done, and then growth, not just growth on the company size, but continuous improvement, learning, education, curiosity. We're a licensed electrical contractor, and we've got a whole bunch of other certifications. And like I said, we've done more than 1,000 projects, and so we bring that experience to you. Be these military, commercial, high-rise, residential, multifamily housing, agricultural projects, and of course residential. There's a neat project in Columbus, pretty iconic piece of the skyline, and there's Michelle, our CEO, and myself in front of that building. We are, unlike some other businesses that are getting into this for some kind of a get rich quick or build it and flip it kind of a driver, we're in it for the long haul. We're focused on long-term, stable, careful, cautious growth, high integrity, and we don't have to answer to any investors driving, some kind of a monthly or quarterly return. We're doing what we believe is the right way to do business. So the solar resource in Ohio, yes, it is cloudy in Ohio, but it's got enough sun that thousands of people are going solar, and it works. So this chart here, this is a solar irradiance map on an annual basis. That's really what counts. We're going to have some clouds and some snow in December in Cleveland for sure. But what we model for each project, no matter if it's a Cincinnati or Cleveland or Indiana, is annual performance. And so this model shows that here we are in Ohio with a light green. Obviously, San Diego, California is going to have higher solar performance than we will. But this map here of Germany is pretty poor solar irradiance. Yet Germany is one of the top solar countries in the world. So this shows that even with moderate solar performance, you can still do a lot with solar. The limitations are less about the irradiance and more about the cost of energy, any kind of subsidies such as our federal tax credit, and obviously just your return on investment. As I said, there are thousands of projects across the state of Ohio. When we started this 20 years ago, and we're talking to people about solar, they really had their doubts. That really has changed. These days, when customers call us asking about solar, they've already seen solar on rooftops of factories or office buildings or universities, and they understand that it's been around for a while now. People understand that it works. So we're certainly not in the early stage of technology adaptation, where we're entering the early majority as more and more people are doing this because it's proven. All right, so the technology itself. So it's pretty simple. For most of our systems, we've got two core components. We've got the solar module itself. There's no moving parts. It's silicon wafer, just like our computer chips. Glass, a little bit of metal, some soldering to bus bar it all together. And then over here, this is one example of an inverter. The inverter takes the DC solar electricity and converts it into alternating current and matches whatever our building is. In a commercial building, it's typically 480 volt, three-phase AC. In a residential building, it might be 240 volt AC. In any case, the utility companies allow us to do this largely because the inverter has built-in safety features that no one has to be monitoring it. It's all automated. And if the utility power goes down, or if someone's doing service in a wing of a factory and shuts down power, the utility, or so the features of the inverter sense that, and within a 60th of a second, one cycle, turn off the AC output, and then watch and monitor for the power to be restored. And after it's been back up and stable for 5 minutes, only then will it reconnect. Now, how this works with your building is the solar modules are up on the roof of the building, or maybe in a field adjacent to the building. They go through the inverters. The inverters are sometimes inside the building. More often than not these days, the inverters are co-located with the solar array on the rooftop or on the ground mounts. They're typically rated for full weather exposure. We meter that and put it through appropriate, breaker panels. And then we inject it into the same load center or breaker box that serves the building. And so some of the power from the solar array will go straight into the building. And if more of the power is made than the building's using, the excess will go through the utility meter and out into the utility grid. That concept is called net generation, or net energy metering, or utility interactive solar. And then at nighttime or on a cloudy day, or when the building's loads exceed the amount of power being made by the solar, the utility is still there to have power going into the building. So most of our clients are designing around their rooftop or a budget, and are not powering 100% of their operations with solar. We're seeing maybe 50%, 75%, 80% of the annual usage being from solar. Now that means on a Saturday when systems are not under a lot of strain, it might be 100%. And then at nighttime, 100% of the power is coming from the utility. So on an average annual basis, maybe 50 to 75% of a building's power might come from a solar system. Now, one of the reasons why solar is really taking off, and we're as busy as we are, is this curve here. This is a great chart that really shows two different things. One is the unit cost of a solar module. So this is in price per watt. And way back in 1975, it was $101 per watt. In this chart, as of 2015, it was 61 cents. It's even lower than that today. And the reason why that cost has gone down is because of volume manufacturing. It's simple economies of scale. And it's a virtuous cycle. The more power is produced by the factories, the more people use it. The more people use it, the lower the price. So this is a little out of date, but the trends have continued. Now there's some diminishing returns. You can see how this is flattened out. This is a lot of R&D and technology. And then this is basically automation and robotics. And then this is basically larger and larger factories as a function of the overhead, the CEO and the marketing team's costs against the number of modules made by that business. So we don't project any magic silver bullet of technology to come along. We're tracking this every day. This is what we do. What we're seeing is just slow and steady, continuous, small improvements in the cost of manufacturing. Energy storage. What you're seeing in this picture is a BESS, a battery energy storage system being installed. It's usually these at the commercial scale are outside of buildings. We're installing several of these this year. It's now just becoming more and more cost effective. It's still a little early in Ohio. When we pencil this out for commercial clients, usually we end up not moving forwards with the deal because the economics are not quite there yet. That same price curve that we showed for solar is also happening for lithium-ion batteries. And so we expect in Ohio that about half of our commercial projects might have a storage component in the next 5 years. But right now, it's the clients that we're doing this for are doing it for either resiliency or ancillary services or peak shaving. And they're doing it as a demonstration project, et cetera. Some of these projects can get very, very large. Picture a tractor trailer truck sized battery and inverter and electronic system outside the building. So it can be done inside at a smaller scale as well. And we do have some clients, commercial clients, that do want to have battery powered backup for their key infrastructure during a power outage. So we can do that as well. All right, performance and durability. So again, we've been doing this for 20 years, and our goal here is to do it for another 20, 40, 60 years. And if we're doing that, we're making people promises that we can keep. So we are developing models of what each individual customer's system will produce. We're basing that on NREL data, National Renewable Energy Laboratory data, and US weather station data. We've got 38-year-old climactic models that, it can vary a little bit year to year, but over a 5-year average, it's very steady. And over the design life of a system, we can get very accurate of how much power is going to be produced on your rooftop in Cincinnati or your rooftop in Akron. We take into account shading. That's what you're seeing in this cool looking picture here. It's a combination of LiDAR and 3D CAD modeling along with some shading analysis that shows where some areas will perform more and some less. We take that into account when we put solar on the rooftop or on the ground mounts. We take temperature into account. We take soiling from dust in the air and maybe snow on the modules. All that goes into our promise about how much power is going to be made. And it's kind of hard to read, but this is a typical breakout of all the different factors that reduce the output of a system. We also do this on a monthly basis. So this kind of a light green is a typical power curve over the year of one of our customers' solar. And you can see, as you would expect, there's more solar resource in the summer months than there are in the winter months. And then the blue bars are their monthly energy usage in kWh. And so in this case, the system is sized so it meets most of their load, almost all of it in the summer, and maybe 20-25% of it in the winter. Now, degradation. This is a really important factor. When we do model a system, people are making an economic investment in it, and they want good information. And so we do model in the performance next year and 10 years from now and 30 years from now on the system. And one of the factors that does happen, it's a very known, scientifically measurable thing, is annual degradation. Today's 100-watt module will put out a little bit less power every year. And the median is typically about 0.5 percentage point. So that in 20 years, that same 100-watt module will probably be only putting out 9. Now, different module manufacturers and technologies do have different degradation rates. And that's very important for us as we evaluate which modules we're going to purchase for our clients Degradation rates is one of the things that we focus on. So as I said, we're typically modeling a 30-year design life. There's nothing magic about 30 years. There are systems from early manufacturers in Japan, such as Kyocera, big global multinational, that are now almost 50 years old, and they're still being monitored daily, and they're still putting out the expected performance. There's no moving parts, nothing to wear out. But 30 years is typically one of the design lives that we'll use in our economic models. The module itself has a 25-year warranty. The inverters have 12 to 25-year warranties, depending on which inverter you use and if you purchase a warranty extension. The racking, the components that hold the system to the rooftop or on the ground, is typically 20 to 25-year warranty. It's either galvanized steel or aluminum and stainless. Depending on what company you use, 1 or 2 year installation warranty is typical. Third Sun Solar offers a 10-year warranty. And then we offer service and maintenance. The majority of our large projects actually hire us to install it, and then we have an annual preventative maintenance and safety check that we do just to keep things running at optimal. This little graphic here shows you the linear warranty of one of the manufacturers. This one, Hanwha Q-Cells, a German and Korean manufacturer that we use. Let's see. So penetrations. Maybe the owner of the company is really excited about solar and brings it to the board. And the first thing on a lot of people's minds are, what? You're going to make holes in our roof? Are you crazy? So that's a typical project. We've got, I think this one's about 100 kW. This is up in Cleveland for a unit of government up there. So as you can see, this is a flat roof, a ballasted, actually a tar roof. There's our crew. They just wrapped up the install. We got a nice little drone shot of them. So these systems are held in place by ballast block on top of a racking component, and then that actually has a slip sheet between it and the rooftop. So this is called a ballasted racking approach, and the majority of our projects have 0 penetrations. Sometimes we'll have some penetrations. Sometimes we'll have a conduit that brings electrical current down to an electrical room. But more often than not, we avoid all of that and have 0 penetrations in the roof. Here's another shot of a different project. So this ballast block is tuned. We'll have 2 blocks here, 4 blocks there. It's all part of the engineering that holds it down to meet whatever design standard the building is under. If it's up near a large body of water and it's exposed, it might be 90 or 120 miles an hour. If it's more inland in Ohio, away from the lakes, it might be 60 miles an hour. And the other design standard is making sure that additional weight on the roof doesn't put the building's integrity into danger. So we'll look at a structural analysis of the rooftop and get sign off and a stamped engineering plan to make sure that we're safe. All right, the economics. Our commercial projects, some of them might want to go forwards for marketing benefits. Some of them have sustainability drivers. We've got some large global clients that have operations in Ohio that have hired us to do projects, and the economics were not as important as their overall commitment to sustainability at the corporate level. A lot of European companies have mandates to do just that. But that said, the rubber hits the road in any business. It's an economic decision, and people can assign a value to the marketing advantages of bringing more clients in or bringing more employees in. But most often than not, it's to save money on electricity over time. So by owning your own solar array, you're protecting your business from cost volatility. We don't know how much the cost of energy is going to be in 10 years or 20 years or 30 years or 1 year. It goes up and down. More often than not, it goes up, but it's volatile. And so in Ohio, according to the EIA, over the last, I'm not sure of the dates. I should pull this graph and add it to my presentation. But I think it's about 10-year, maybe 15-year period. It's averaged about 3.2% annual utility cost escalation. So it varies depending on who your utility is. It varies depending on how large of an operation you are. If you're buying energy on a industrial scale, you're going to be paying a lot less than if you're buying energy for a dentist office. So that's why we look at each customer's utility usage patterns on a case by case. Simple payback of recouping the amount of money you invest is between 5 and 12 years. And of course, that's a big range. That's just to give you an order of magnitude. Our clients bring us their electric bills. We look at their usage patterns. We look at their assumptions, their specifics, and we give a report of their economics. The internal rate of return of these investments is double digits. It can be higher than 20% if people leverage it. If people actually borrow money, it can go way up. So everyone's different, and we work with you and your CFO and your accounting team to come up with the maximized return for you. So I've been talking about capital investments. That's our most popular way for people to put solar on, is they simply own it and take the tax credit. They take the accelerated depreciation, any other benefits. But for schools and universities and units of government, the most popular way for us to do solar projects are with a power purchase agreement. And that's a whole nother slideshow. We're not going to go into the details of that. But in short, it's a third-party owned system where we'll install solar at XYZ University, and it will be paid for by a private investor who takes the tax credit, borrows money on their balance sheet, owns and operates a solar power plant on the roof of that university. And all the university does is agrees to purchase the power made by that system at an agreed upon rate for typically 20 to 25 years, a power purchase agreement. That gives them lower energy costs and a locked in energy cost, gives them the sustainability that they want. And also they couldn't take advantage of the tax credits. So it's a tax efficient way for these systems to operate. So a couple case studies. So here's a university we did. It's a ground mount, it's a tracker. So you're looking at 2.33 megawatts or 2,330 kilowatts of solar. When we installed this, it was the largest solar array in Ohio on a campus. And it offset about 15% of the energy's used by that campus and 10% of their CO2 footprint. That counts their fleet, counts a pretty thorough carbon inventory analysis. Here's a corporate campus we did. It's a combination of parking lot shading structures as well as rooftop solar. It was over 3 different roofs, 15 solar canopies. And the interesting thing about this project was this is a 24/7 data center with 3 shifts. So those parking lots were full all day long, all night long. It was a safety-focused installation. We set up an offsite parking lot with busing, and the project went very smoothly. Here's a smaller project on a nonprofit institution. Here's a project we did for higher education university in Ohio. Let's see, this is a municipal nonprofit, the acronym Metro RTA. They've hired us for 4 different phases of solar installation. They're so bullish on solar. This project is one of the more unique ones we've ever done. Number 1, because it's a curved roof. Number 2, this was the first US military installation to be 0 net energy in the nation. Here's another federal project we did. This is visible between Athens and Columbus on the side of 33, pretty iconic project. And now we'll open it up to Q&A. Caitlin will take a look at some of the questions that have been submitted. And if you have more questions, type them into the chat box.
Great, thanks, Geoff. We've had quite a few folks join us since we started, so I'll remind you all that there's the Q&A section as well as the chat feature down at the bottom of your screen. Feel free to type in questions that you would like to have answered by Geoff. We'll go ahead and start with our first question from Kevin. Kevin's wondering if we've had commercial or residential projects that needed to modify or upgrade their roof to allow for the weight of the solar components. And if so, did we work with them in the design of that roof, or recommend outsourcing this for update?
Yeah, great question. So the answer is yes, we have. And so I'll break it up into residential versus commercial because they're somewhat different. So in residential, the driver is less the weight pushing down on the system. Residential comp shingle roofs typically will lag into the roof structural member, the truss, and the structural analysis design driver is uplift from the wind or pull out. But that said, we have had some projects where we go into structural engineering and they will not pass it. We will not give it a stamp. We don't recommend it. We call it unsafe and recommend either buttressing the trusses or adding cross bracing. There's several things that we can do. Sometimes we do that. Sometimes the customer hires it out to a local carpenter or does it as a home project. So another example I can recall is a barn, an agricultural project that we did. And in the barn, we had typical large trusses on maybe 8-foot centers and then horizontal girts going east-west. And in that case, same concept. The engineer structural analysis said that we needed to add some wood. And so the customer in that case did it themselves. On commercial, it typically will cost a lot of money to disrupt the occupied building to go up and do what's typically a steel retrofit. And so we've had commercial projects where when we got to the structural analysis component, we hit what we call a fatal flaw. And we decided there's no way we can get this done safely. Maybe we look at a ground mount. Maybe we can resize the ballasted to have some mechanical attachments with penetrations, fully flashed, done by a roofer, but that would reduce our pounds per square foot. But sometimes I can think of 3 projects where the project just decided not to go forwards. It was too cost prohibitive to structurally reinforce the roof. But this is, tens of thousands of designs and projects we've done. Maybe 3 have not gone forwards. So it's very rare.
Great, thanks, Geoff. We haven't gotten any additional questions. If you do have a question, please send it in. And I will go ahead and let you know now, as you're thinking about your questions, we will follow up with you all with a copy of this recording of this webinar, as well as some additional resources, as well as a survey. So if you would, please do take that when you do get it. Kevin did follow up with an additional question. He says, have you had companies come to you when they are in the building stage to prepare for an install on a roof?
Yeah, actually that works nicely. We can be integrated with their construction in their design. We're doing that right now on 3 projects. And so there's kind of 3 advantages. Number 1, a lot of times, I wonder if there's a good picture of a flat roof. We can coordinate with the other trades, the mechanicals, the plumbing, and avoid rooftop penetrations. There's our building in Athens, and you can see that little break in the module. That's because this was retrofit. So there is a plumbing vent stack right there. So we can coordinate during the design phase and have a better array with less breaks here and there. The other piece is we can save on engineering and permitting and costs because we can be wrapped into the overall building permit. And then the third piece is a little bit of efficiency is we can oftentimes run the conduit inside the building while the electrician's doing all the other work there. And it's a little bit more efficient to do that behind the drywall while all the other electrical is being done. So it's nice to integrate in early in a project. Thanks, Kevin.
Great. And I'll remind folks who are on Facebook Live as well, you are welcome to ask questions. We're looking there too. We've got another question. What type of penetration warranty is included with an install?
Sure. So if we do have to make a penetration, we will warrant it for 10 years. That's our standard installation warranty on all of our work, electrical work, as well as any kind of penetration. More often than not on a commercial work, we'll actually hire the client's roofer who might still hold an active warranty and have that company do the penetration on our behalf as a subcontractor. That keeps it simple, keeps it professional, although we do have experienced commercial roofers on our staff. If it's a residential roof or a barn roof, where we are on a slope and we're using lags, we'll be fully flashed. I don't have a good diagram on here. That's more of a residential building detail. But basically if they're shingles, they're lapping each other. And we have a large sheet of aluminum that weaves into the shingles, just like a plumbing vent stack is fully flashed. So we can safely and confidently warrant that it's leak-free for the 10-year period. And of course, if there are leaks, and we have had leaks in our thousands of projects, very few, they show up immediately. They show up right away. I'd love to say that we're 100% leak-free, but that's absolutely not the truth. And I don't think anybody doing any kind of commercial construction, has never had any kind of an issue.
Great. Thanks, Geoff. Another question, are there jurisdictions or utilities that are more or less friendly to solar? And how does that affect one's decision to go solar?
Oh, wow. I wish I could say that it's always easy. So jurisdictions are not so bad. Again, we've been doing this for so long and we're so, well known in the industry that we already have relationships with the building departments of everyone in the state of Ohio and Indiana and all the major metro areas. Sometimes inspectors don't even get out of their car if it's raining out because they trust our work. I probably shouldn't say that. I don't want to get anybody in trouble, but I am proud of our reputation. Now, when we go into a village or smaller town and it's the first solar array there, it's typically an education process. And we're very patient. We've done this, many, many times. And the AHJ, the authority having jurisdiction, it's their job to make sure that health and safety of the citizens are protected. And they usually have a lot of questions. And we win them over and give them all the answers and educate them. And in one case, it's turned into an installation for that inspector. So that's the good news. Sometimes there's zoning where we have to do renderings. Historic districts can be complicated. If we've got a building that's in a historic district, we've got to be able to prove that the solar array on the rooftop is not going to change the historic nature of that district. We do all that as part of our project's full service approach. The second part of that question was utilities. Now, the investor-owned utilities, First Energy, Duke Energy, American Electric Power, and their subsidiaries, they're actually relatively easy to work with. They're very professional, and they see enough of these projects from us that it's very straightforward. There are rules and regulations. We abide by them. There's an application process, and we go through the interconnection regulatory process. It's the smaller utilities, either the rural electric co-ops or the smaller municipals in towns and villages, where it can really vary. And oftentimes we'll work with our clients to have the utility update their net metering rules and their utility interconnection rules. We'll point to the big investor-owned utilities and introduce them and say, you can talk about how this impacts safety and performance and everything else, and they get comfortable with it, and they can move forward. So I'd say if you're in a major metro area working with a publicly regulated utility like American Electric Power, no problem. If you are have a facility in a smaller area served by a rural electric co-op, it's one of the things we do at the feasibility stage of a project, is to make sure that we don't get all excited about the project and then find out that it's limited to only 25 kW, not 250 kW, or even worse, not allowed to go forwards at all. Caitlin?
Thanks. We do not have any additional questions at this time. So I don't know if you have any final words, Geoff.
Go solar. Yeah, thanks so much, everybody, for tuning in. And one of the things I didn't cover on is timing of these things. And I didn't talk about the federal tax credit. So I probably need to update my presentation to include a slide on that. So I predict that in 10 years, the cost of a system will likely be slightly lower than the cost of the same system today. I predict that in 10 years, if we're roof constrained, if we're maxing the roof, we might be able to get slightly more power per square foot with technology in the future than today's technology. That said, there's federal subsidies and tax advantages for going solar. The federal tax credit is set up right now at 26%. So that means that you do a $100 project, $26 comes straight off your taxes. And if you're making quarterly payments, you can start right away and start saving money on today's cash flow by making a reduced quarterly payment. That tax credit drops for next year down to, I believe it's 24%?
22%.
Worse, 22%. So it goes from 26% down to 22%. And then after that, Caitlin,
10%.
what is it? It goes down to 10%. So that big utility or that big federal tax benefit is going away. So there's no advantage to waiting. The cost might go down by 1% over a couple of years, but your tax credit is going to go down significantly. And that's fine. That tax credit has helped the industry for years, but because of the natural price curve and our efficiency of installing and the rising cost of energy, in my opinion, we don't really need that tax credit much more. I'd love a level playing field where other dirty forms of energy don't have their own subsidies and tax credits. But in any case, I don't expect that tax credit to be extended. It's a sunset that's predictable. It'll go down to 10% and stay there, and that's fine. So time is of the essence to get your system modeled, and it's a typical 3 to 4 month period to get the system all the way through permitting, and then the installation can really vary. This system, I think the crew was on the roof for only a week. So the actual installation is very fast, but all the regulatory permitting, utility interconnection, application planning, procurement, all that, and getting on our schedule has a longer lead time. But once more, I appreciate everyone tuning in. And again, we're in this for environmental reasons. We're in this for planetary, climate-driven reasons. We've been talking about economics because that's what our commercial clients are typically doing. But for us, we're a mission-driven organization. Caitlin loves doing stuff with solar because she's a tree hugger like me, and it's a way for her to use her professional talents to be part of the future. And then at a state level in Ohio, we are playing catch-up, and we're trying to position our state to be modern, high-tech, and positioned to operate over the future. And it's exciting to see more and more folks here in the Midwest grabbing on to solar as they get used to it and comfortable with it. So thank you, everybody. And You can contact us at the end of the slideshow and follow up and set up a custom one-on-one review of your situation. Typically, we're not going to come and try to have a meeting with you until we've taken a look at your utility bills, taken a look at your rooftop, done some preliminary modeling. A lot of that can be done very conveniently. And in this day and age from COVID, we can do it at safe distancing until once more we can, be close to each other and shake hands without any kind of health precautions.
Yeah, and I'll include all of that information in the follow-up email you all get. So if you are interested in reaching out and talking with someone remotely, we'd be more than happy to work with you.
Thanks again.
Yeah, thanks
Signing
everyone.
off.
Bye-bye.